Okay, so we're now going to look a little bit more in depth at assignment number 1. So as you start working on these things, I want to be sure that you have a good handle of what is expected. So let's look at assignment 1. As I pointed out earlier, remember there are 6 kinematic diagrams that you're going to create. And then corresponding to those kinematic diagrams, you're going to do the mobility equations. So really, I like to say there's not 12 problems here. There's 6 problems with a diagram and mobility equations, okay, that correspond to each one. And then there's going to be 2 case studies at the bottom here that are at the end of the chapter that you're going to do. So what I want to do is I want to go to the end of the chapter. Now, if you don't have your book yet, I do have a PDF of Assignment 1, Part 1, copy of the problem. So if you click on here, this is the PDFs of each one of the problems from the book, okay? Because I know some people are still waiting for their books to maybe arrive if you're getting them, online. So that's there for you to use if that's what you need. Or you can go to the end of your book, page 25. So I am going to open up my book. And the first problem that you guys are going to be doing is problem 1-1, okay? This is a mechanism that's used to open the door of a heat treating furnace. And it is shown down here in this illustration. Draw the kinematic diagram of the mechanism. The end of the handle is identified as a point of interest. So what we have here is we have a handle. At this point, this is connected to the frame, all right? So this is going to rotate, if you would, or oscillate about this point. Then it continues, and it's going to be connected to a connecting rod that is going to go down. And this bottom portion here is the door that goes up and down. So this is a slider. Okay. All right. So you've got a handle, you've got your frame, your connecting rod, and then your door going up and down. Should be a 4-bar mechanism, and you should get a mobility of 1. Okay. Because you're only moving the handle here for this door to go up and down. All right. So that is your first problem. Any questions so far? Okay. Now, notice that this says problem number 1 and problem number 26. So problem number 1 is the diagram. Problem 26, if we go forward, this is where it says for problems 126, or for specify the number of links and the number of joints to calculate the mobility for each one of the mechanisms here. So 26 is the mobility equation for problem 1-1. So you're assigned 26 and you're assigned 1.1. All right. And remember, write out the mobility equation, fill in your numbers, and then final answer. Okay. In one of those 3 ways that we identified. The next one you're going to do here, if we go back to the beginning of the problem section, you're going to do 1-3. 1-3 is a folding chair, commonly used in stadiums. So you'll notice here that this is going to be the frame. The seat is what is going to rotate up and down, okay, up and down. So it's going to rotate about this. And then there are 2 links that are in the middle here, okay? So kinematic diagram, 1-3. And then if we go to the end, 1-28 is the mobility equation for that same figure, okay? So now you've already got 4 problems done. Isn't that good? It's way easier than you thought. Turning the page, 1-9. This is a toggle clamp, just a little bit different configuration than what we looked at earlier, okay? So you're going to draw the diagram, and you're going to do the mobility equation for the corresponding number. I'm just looking here. It doesn't say anything about a special interest point on this particular problem. So you can put one in, you don't have to. I'll leave that up to you. You're the designer, okay? You're the designer. So you maybe don't have to put an X or a Y. Not required, not required, okay? The next one we have here is going to be problem 1-10. Problem 1-10, this is a child's digging toy that is commonly used in municipal sandboxes at parks. Draw the kinematic diagram of the mechanism, and then for the corresponding number at the end, you're going to calculate the mobility. Okay. The one thing that we have here is, you'll notice that we have like this T link connected to the frame. Okay. So right here, This link right here is all one element, okay? You can't really show it as a single triangle, all right? So what I would suggest doing, and this is how I've noticed that it's the easiest. If you go with something like this, okay, where this is connected to the frame, okay, that would be down here, all right? And then you would have a connection right here. These would be the 2 points, and then you're going to have a connection at the end with the scooper. That makes sense? Okay. Don't make it single lines going up and over. It's going to look like, 2 or 3 different elements. Okay. And again, there's not an easy way to do it with a single triangle. So something like this kind of makes sense. Okay. All right. And then the rest of it is kind of, the way you did before. This one is not a mobility of 1. Okay. If you've ever operated one of these, takes a couple tries. Okay. So it's not 1. The mobility is not 1. So, so you're going to find this one's a little bit different than the others. The next one that we have is number 111. The description is at the bottom of the page, and it's referring to the reciprocating saw that's up here, okay, at the top of the next column. So this one, this is the inside of a reciprocating saw. You'll notice that the blade is the end point. So the blade is what's going to be going in and out. This is a slider, okay? This is going to be a sliding mechanism. Then what you have is the connecting rod if we go backwards, and then it's connected to this circle, okay? How do we show that? All right, that we haven't seen yet. So to show that type of a configuration, what you're going to do is at the center here, this is going to be our frame. So you're going to show, I'm going to show it this way, the inside being the frame, the center of that circle. So I'm just going to draw a dotted line. This is that circle going around. You're not going to draw a dotted line. And then you have connected to that circle, the connecting rod going up to the slider, okay? All that this is this is a rigid link. The radius is going from the center of that circle to the edge of the circle connected to the slider. So you are going to represent this with just a straight line, if you would, radius link. Does that make sense to everybody? Okay. So, and don't draw the circle. You're just going to draw a straight link from the center to where it connects to that connecting rod. Does that make sense? Simplifies it a lot. But again, that's what a kinematic diagram does. What the actual link looks like, that's for you to design later on. Okay. So it's kind of like a flywheel, right? Mm-hmm. Okay. So that's what that one, looks like. Drew.
So in the CAD drawing, you wouldn't put it in that either, right?
Like, say it again. You wouldn't put the what in?
The AutoCAD drawing. Yeah.
You don't put the circle. No. You just put it represented as a straight link, which would be the radius, if you would, of that circle. Yep. Mm-hmm. So there's that one. Okay. Then if I turn the page, the last one you're going to do is number 1-24. Be careful with this one. If you're not listening to me right now, listen to me now. Okay. Because this is sketch the sewing machine as shown in figure P124. It is not this illustration directly below. It is actually up here. Okay. It is figure P124. All right. So just be careful. All right. Now here again, sewing machine has a little flywheel on it. Okay. It's going to represent just like that reciprocating saw did. So the center here is going to be your frame, and you're just going to show a radius to where it connects to the connecting rod to the slider going up and down vertically. Okay. All right. So that is the last problem. And again, each one of these 6 diagrams and 6 mobility equations correspondingly. Okay. Then there are 2 case studies at the end. 2 case studies at the end. Case study number 1, this is on page 29. We have a mechanism shown directly down here. It has been taken from a feed device of an automated ball bearing assembly machine. An electric motor is attached right here. So this goes around in a circle. Carefully examine the configuration of the components of the mechanism, then answer the following questions to gain insight on the operation of the mechanism. So there are 6 questions to answer, okay? When you answer these questions, answer them in a way that you would be presenting the answer, for instance, to your boss, okay? So if they're like, hey, answer, tell me about the mechanism out, on the shop floor, go out and get me the answers to these questions. I want you to answer these questions like you would be presenting it to your boss. All right. And I hope that speaks volumes. All right. Not just yes, no, maybe, kinda, I don't know. All right. So that's gonna be your first one. The second one that you have here, you're going to turn the page and it's going to show a mechanism of a typical tank. They call it of a water closet. It's the inside of a toilet, okay? And how that drains out. So there's a mechanism in there. Now, if you want to look at and compare this mechanism to the one that you probably have access to at home, do that and see if yours is similar or different than how this one operates, okay? And then again, answer the questions that we see here as well. All right. So 2 case studies at the end to round out the assignment. So if I go back over here, when you hand in your assignment, each one of these diagrams is going to be using AutoCAD, okay? And then your mobility equations, again, can be either handwritten on the CAD diagram or in the Word document that you create for this, okay? One of those 3 places. And then when you do your case studies, you're answering questions like you're going to explain the answers to those to your boss, okay? And remember, you want to make sure that they can understand what you're trying to communicate, okay? Any questions at all? All right. You'll notice here number 6 says, I'm just noticing, convert to a PDF. You don't have to. You can upload the regular Word documents. That's totally fine with your screen snips and such. Canvas accepts that now. A year ago, they didn't. It's kind of updated. So, all right. So if there aren't any questions, then that's all that I have for the assignment overview.